beginning of the body of that function. And this closing bracket marks the end of the function. This is a print statement merely to display a message on the screen. And the format is you'll have the word, the command itself, printf. And in brackets, inside double quotes, you'll have the message you want displayed on your screen. Whatever you type inside the double quotes is what will be displayed. And if the program successfully ends, we mark it with return 0. And if we run that, you will see the program says, welcome to programming. That's the output. If you wanted to say something different, you can say, for example, SMA 191 is fun. For example, if you want that to be output to your screen, that will be what the program will display for you. I want confirmation that basic program is well understood so that we can move on to other things. Yes. Some of you are raising your, I see someone raising a hand. Then, who is this? Njeri Nganga.
I'm asking if you could repeat.
Njeri Nganga, you have your hand up. Richard Mukanda, you have a hand up. What is it?
I'm asking, I'm trying to request if you could repeat.
Or you want me to repeat that code?
Yeah.
All right, I'll do that. I'll do that for the benefit of those who are probably attending the class the first time. I'll repeat the entire code. Anyone who has something different, I'm going to write the code from scratch. So this is the compiler, the link. I can even click it from the one I've shared with you on message. It's this one, so that it opens like that. And what I will do now is I will remove everything from that screen so that we write everything ourselves from scratch. So we said when you're writing a program, you could start with some comments. Maybe some of the comments will be on a straight line. We call them single line comments. For example, this is a C program. Or you could do in multiple comments, or what we call multi-line comments. You could have the forward slash with an asterisk. Now that means we'll have more lines. For example, you could say this program, or this C program would be used to explain examples of C programs to beginners. So if you want your comments to run through more than one line, you would need to use the multiple comments, the multiple comment symbols. That all those are comments. Then you need, at any point if something is not clear, you can unmute yourself and speak up, because I may not be able to switch between the two windows. Okay, so this is a single line comment. It runs one line. This is a multi-line comment. You can do it for more lines. Every C program would require a minimum of one directive, and the directive we'll be using is the hash include the standard input-output header file. This code here is simply saying, copy to our file, to copy to the file we are writing. The file is main.c, C being the C language extension. So we are simply asking the C environment to look for a file called stdio.h, and that means the standard input-output functions file. And for input, we'll be using the keyboard. For output, we are using screen or the monitor. And this is the extension of the file, h being header. We are including it. So with that included, it means now we can be able to use functions for inputting from the keyboard and the functions for outputting to the screen in our program. Every C program requires the main function to be there at minimum. So I'll say int main. Now, it's int main because the function main usually returns 0, which is an integer, when it is successfully completed. When the function, every function returns a result or returns some output. So the main function returns 0 when complete, when it has done its job successfully. But if you want to debug the program, you need to return a different number or a different value like x. So by default, if you suspect or you believe your program is okay and should be able to return the correct results after successful compilation, you got to return 0. So that's the purpose of this. We are saying we have a function called main, and the main is an integer, meaning it's going to return an integer being a whole number. And of course, the brackets here, all functions are preceded by 2 brackets. We call them parentheses. Here, we don't have any arguments in brackets. And this opening curly bracket marks the beginning of the body of the function. And this marks the end of the function body. So inside here, inside the opening curly bracket and the closing curly bracket is where we write our code. Up to that point, are we okay before we write anything in the main function? Is that template okay?
Yes.
All right. So let's continue now and put some stuff in the code. Now our primary coding will be inside the opening curly bracket and closing curly bracket. Our first program has only one basic function to send a greeting, to display a greeting on the screen. Then we'll advance that program bit by bit as we do more things. So one of the functions that is found in O, remember stdio is standing for standard input output. So we want to use one of the functions in the O file, which is called printf. Printf function. Now the printf function is simply for displaying or printing something to your screen or your monitor. And whatever you print, remember I said all functions are brackets. All functions. Main is a function, it has brackets. Printf is a function, it has brackets too. Guys, control your mics. Unless you are speaking to the class, remain muted. Unless you are speaking to the class, remain muted. Do not converse between yourselves or among yourselves. That will be confusing and a distraction to the rest of us. So the main function is here. It has brackets. The print function is here. It has brackets. But the purpose of the print function is to print a message on your screen, to print a value on your screen. So what we are printing is a string, text. Text is usually enclosed in double quote marks. So we put the double quote mark inside the brackets and we print our message, welcome to C program, like that. So whatever message you put inside the double quotes is what this function will display on your screen. And if you believe that's what you need to do in your program, then you can mark the end of that program by simply saying return 0 at the end of that program. So the program looks like that. Simply displaying the message, welcome to C programming, up to that point. And when done, that marks the end. So marks successful completion. That's a comment. The return 0 marks the successful completion of the comment. And the function here, printf is a function for displaying something on the screen or a monitor. Okay, I'm just putting comments here to help you understand what we are coding. So if we run this, you see it saying, welcome to C programming. Where is this coming from? In the printf function, we have that message. If I change it to something else, if I say 2025 is a great year, that's exactly what you'll see printed out. So this is a very basic program, but as usual, all complex programs begin using basics before you can use anything else. So I would delete the comments so that we have a simpler program like this. Okay, and I'm going to share this code in the chat window. You can copy it and run it. Some of you are saying you can't see my screen. Is that true? Because I think I am remaining in presentation mode still. I can't see. Jerry, you can't see my screen. Is that true?
Yes, I can't see it.
Who is able to see my screen? Maybe it's all of you or it's some of you.
I can see the screen.
I can see.
Yeah,
can
so
see
then
it.
it means, JD, what you can do is,
I can see the screen.
thank you,
It is
thank you.
uh,
JD,
I
close
can
the
see.
window and join again. Those who can't see what I've shared, close the meeting window, then join again. Click the link again to join. Someone saying in case in size that handwriting or increase the size. You are saying you want me to zoom a little bit. Someone to confirm? This one has been commented by, who is this?
Better.
Wendy, are you okay now with the size? Someone was talking about the size. Waku Nasira, is the size okay now? This one?
Yes.
Okay, thank you. So we'll continue. So with that, that's a basic message. So now I want to show you the basic programs you can write when you are manipulating numbers. I want us to be comfortable manipulating all the numbers using all the arithmetic operators, relational operators. So let's do basic. Let's do a basic calculator. Basic C calculator. Okay, a basic C calculator. So we will, in our program, we will ask a user to enter two numbers, then we can add, we see what happens, we subtract, we see what happens, etc. So enter two integers, or enter two numbers. So here, it's a message that will appear on the screen asking a user to enter. So, but before we run our program to do calculations, we need places to store our data. Because we are going to add two numbers or multiply two numbers or divide two numbers, we need variables. So I can say int num1, the first number, int num2, the second number, int results. Okay? Int results. So we will have our first number being num1, our second number being num2. The result will be stored here. So first case, enter two numbers, and we want to enter those two numbers using scanf. The scanf function, we format the two numbers we want to enter, and we format them using %d. %d, those are the two numbers, okay? The two numbers will be stored in and num1 and num2. So once we have grabbed the numbers, we can now do the calculation. The result equal to num1 plus num2. Num1 plus num2, after which we can now print the results. The result will be something like this. We are saying the first number plus the second number would be equal to the results. So num1, num2, results. Then after that, we can say the time. So I don't know whether there are errors, but we'll get to see as we move on. So the program now says, I'll repeat the explanation in case you didn't get it. Enter two numbers. I'll enter a number like 5, space 8. So I've entered 5 and 8. My program says 5 plus 8 is 13. Let me run it again. I'll give it a number like 43 and 8. Add those numbers, it says 43 plus 98 is 141, which I believe is correct. Now the explanation of the code is what you need to know. We are starting here. In our program, we are doing addition. We want to demonstrate how we can add two numbers and display the result on the screen. So to add two numbers, we need the numbers themselves. So I've created a variable num1, which is going to be an integer. Num2 is also an integer. Because we are adding integers, we need a place to store the results. So I've created a variable called results, also an integer. So we have three variables, num1, num2, and results. So the process would be, we want these numbers to come from the user. So we ask the user using a printf command, enter the two numbers. This is what the message is doing. The message just appears on the screen. Enter the two numbers. And now, of course, that statement ends the semicolon. Now we are letting the user enter the numbers using the scanf. Scanf is part of the IO. Input is for scanf. Scanf is part of the input functions. Printf is part of the output function. So here we are saying scan the screen. So scan the keyboard, looking for two values. The first value will be an integer. The second value is an integer. %d is a format specifier for integers. So we are formatting an integer here, formatting an integer here, two of them. But now the real integers will come after the comma and will precede or will prefix the variable name with the ampersand symbol. We are capturing stuff from the keyboard. So variable number one was num1. If you remember, we declared it here. For num1, store whatever the user types first into num1. Whatever the user types next will be stored in num2. Now we'll assume whatever the user enters will be stored in num1 and num2 variables, which are here. After that, we are now doing the calculation. We have a variable called result here. We are assigning the result, the total of num2 plus num1. So whatever is in num1 added to whatever is in num2, the result will be stored in the variable called results. Now that the results contains the answer we are looking for, the output of our program, now we run the printf command. The printf command, we are formatting the results. In it, inside the quote marks, we are doing formatting. After the comma, we do the variables. So here we are saying, when you display the results using printf, this part where we are seeing %d is where num1 will go. The second %d is where num2 will go. The last %d is where result will go. We are simply formatting. We are saying display num1 as an integer, plus, this plus will be displayed as a plus. Okay. Then where num2 is, we also format it as a number. Then we'll put an equal sign. Where there is %d, we display result. That gives you this effect you are seeing here. 43 was num1, 98 was num2, 141 was result. The program ends successfully. So if you try other numbers here, for example, 1 and 9, I'm only putting a space between the two, and it's saying 1 plus 9 is 10. If you want to try why it's always ending successfully, if you don't want your program to end successfully, you can return something else like return -7 instead of return 0, and you will be having those kind of outputs. Code exited with errors. You see the difference? Code exited with errors if you return something that's not 0, okay? But if I change this one to 0, the code exited without errors or ended successfully. So I'll do the same thing 1 and 9, and it says code execution successful. That's the difference. If you try to return something like letter Y, return Y, you see you get errors. The program is saying it doesn't understand what Y is doing here. So you can only return a number. Okay. If you and maybe I'm trying to see whether I can add 9 and 0, say code exited with errors. Anything other than 0, any number other than 0, the code will exit with errors. The only way to end a program successfully without errors is when you have return 0. So in that case, 4 and the 6 will give us 10. Someone to maybe ask a question from that code segment, or simply confirm that you understand the code. Carol, Sele, I see your hand is up. Unmute yourself, speak, then mute yourself. Molinda, Eugene, your hand is up. If you have something to say, please say. Otherwise, if your mic is not working, type a message understood or okay. Just type okay if you are getting it. You can type in the message section, you can type okay if you are understanding it. Yeah, I see thumbs up, so meaning you guys are understanding the code before I go to something else. Someone is asking here, how can we declare all 3 variables in one line? Njuguna Nganga, I'll answer that in a bit. Can we use a different compiler? Yes, you can use a different compiler, but for consistency, I'm using programmist.com. The link is shared with you already. You can see it there. I already shared it in the message section. You can even share it again if you want. There, that's the compiler I'm using. Feel free to use another, but so that we don't have a problem with interfaces being different, let's use a common one. And I can also share the code. Let me copy the entire code and share it with you. There we go. So you can copy it and run it yourself. The code has been shared in the message or chat section. Feel free to use it. All right, I think the only thing that I need to answer somebody here is someone is saying, someone was talking about how do we declare all of those variables in one line? Yes, let me show you that. You go to where the variables were declared, int num1, int num2, and int result. All of these are integers. And so you may not need the 3 lines. You can just simply separate them with commas. Num1, num2, results. So in that case, you don't need the others. That's how you do that. As long as num1, num2, num3 are all integers, you can declare them in one line. And it should work just the same way. 6, 8, giving you 14. I believe that has been answered. Njuguna Nganga, you had that question. Let me scroll down and see whether there's something else. I've shared the code. I already explained in class, the work of a compiler is to check your code, evaluate your code for syntax mistakes. And if there are no errors, it runs your program, it runs your code. So you can Google that out and get more details about what a compiler does. But in a nutshell, a compiler is a special type of software that checks a program's code against the syntax rules. And if the rules are obeyed, then there are no mistakes in the program, the compiler can convert that file into an executable file, which is in machine code, zeros and ones. Okay. Mine has given me an error. Yeah, you're going to find those challenges. What is the purpose of Visual Studio Code, please? Guys, don't mix yourself up. Let us restrict ourselves to the tools I'm using. If you start investigating and trying out different tools, you'll be causing distraction in class. Because now, if I switch to explaining Visual Studio, we will not be doing what we are doing. So some of these things you can Google out and find out what they are. Just use the one I'm using, and I think I insisted we use the same thing I'm using for consistency purposes. So we have done a simple program for addition. Maybe I will convert it to do subtraction, which is going to be straightforward as well. So if I want to do subtraction, I'll simply change. So the result, instead of addition here, I will change to subtraction. Okay. So let me introduce code here and saying printf subtraction test. Let me call it that. Subtraction test will be there. So in my case now, I simply want to do this program for subtraction only for now. You have done addition, so I'll make it do subtraction. So same thing, but the operation is going to be different. So let's start with that code. Subtraction test. Then enter 2 numbers. We capture the numbers. We subtract. We display the result. There we go. Subtraction test, enter 2 numbers. The first number is 7. The second number is 9. Enter. Now we need to change this one to mean the correct message. This is going to be minus. Remember, the only thing that is changing is the operation. We are not adding, we are not using the plus, we are using the minus symbol. Okay. So the numbers I want to subtract are maybe 76 followed by 97. 76 and 97, I want to say 76 minus 97. Program says 76 minus 97 is negative 21, which is correct. And that's simply how you implement the subtraction thing here. You are able to get the numbers from the keyboard the same way. Once you have the numbers in your variables, you can do the rest of the calculation. So that is for subtraction. It was run successfully. You can test it out yourself. Let me make it do multiplication test. So enter two numbers, and then once you have the two numbers, you multiply them using the asterisk. Okay, nothing else is changing. This one will be times. So where there was plus or minus, you simply replace. We run this. Enter two numbers, 5 and 7. It says 5 times 7 is 35, which is correct. So I'm sharing the code. You can go try that out. Then I'm doing division test. Enter two numbers. Once you get the numbers, you divide them using that sign. This one will be the division. We run. The numbers I want to divide are 9 and 5. 9 divided by 5, it says 1, which is correct. Because maybe I need someone to tell me why it's 1 and not 1 point. Someone who has been following me carefully should be able to get that answer right, that question right. 9 divided by 5, the program says equals 1. Why is that so? Someone to unmute and answer that question.
Because you are using integer instead of float. Because you are using an integer instead of float.
Oh, you're saying because we did use float. Someone is saying because you have declared it as integers. You guys understand what I'm doing. That's nice. All right. Now mute your mics. It's okay. Someone has already answered. It's because we have declared all the variables as integers. We have declared all the variables as integers. As you can see here, we have num1 is an integer, num2 is an integer, result is an integer, and we know integers cannot store decimals. So any decimal that you have will be truncated, will be cut off. Okay, but in case you wanted the integers to be there, the decimals to be there, then you ought to have declared the variables as floats. Maybe to demonstrate that, we'll do that later on. So for now, let's work with something else. So we have done division. Now let's do remainder. We are doing a remainder test. So remainder test, now we'll do the same thing, except now we are using the symbol, the percentage symbol. Get the first number, divide by the second number, and extract the remainder. So in our case, we'll be saying this one equal to this one. So we run. The numbers I'm having are 7 and 5. You see what's doing? 7 divided by 5 is saying 2. But I want instead of this forward slash, I'll say percentage. So we run 7 and 5. It's saying 7. No, I think there's something wrong there. I may have to escape that. 7 and 5. Yeah, he's saying 7% this equal to remainder that. So 7 and 5. Yeah, he's saying 7 divided by 5 equal to remainder 2, which is correct. When you divide 7 by 5, you get 1. The remainder is 2. And because we were doing the extraction of our remainder, we use the remainder, the modulus operator here. So it's extracting whatever remains, which is 2. And that is correct. Those who want, if you want to work with fractions, then you declare the variables as floats. So this one can be float. Okay, float. So if we want number 1 to be a decimal, number 2 to be a decimal, even the result to be a decimal, if we try that, you will have problems here. You see, we are being told 9 float etc. So let's see what happens now in our program. We have declared things as floating points. So which means we have to format the result as floating. So percentage D is for integers. Floating point is percentage F. So we have to format things as percentage F again. Now not D, for us to accommodate the decimals. So we do that. There's something that is missing here. There's a percentage symbol in line 9 here. There's this one. the program can't understand here. So let's say we were adding. So when we run that, it's saying enter two numbers. Let's say 4.14 or 24. The next number is 8.76. And they're saying, oh, we have our own calculation at the end of the day. So we have the numbers obtained from the keyboard as floating point numbers. The result is num1 plus num2. And as we display the result, we are saying percentage of the first number. We are formatting the second number. This will be plus. Then we are saying we are also formatting the last number. So this one, and this one. So that I have 1.2 plus 4.5. Look at what's doing. 1.200 plus 4.500 equal to 5.700. The addition is correct. It's just that it has so many decimal points. Okay. So maybe I can format the decimals to 0.2 decimals. 0.2. I believe that's where we put the 0.2. Let me see. If I have 3.4 adding to 9.6 or 8, now it's giving us to two decimal places. So 3.40 plus 9.80 equals 13.20. So I've only indicated this is a floating point, meaning decimal, and I want it to have two decimal places, 0.2. It's also a floating point number, two decimal places, a floating point number, two decimal places. If you don't want two decimal places, you can make it 1, so 0.1, 0.1, 0.1, and it will format your results to one decimal place, as you can see here. Okay, so if you wanted to do multiplication, the same story. You could do multiplication test. So you get your two numbers. Instead of adding, you multiply. Instead of adding here, you're multiplying, and that will be it. Which numbers are we interested in? 5.65. The next number is 9.76. Let's multiply those two. It's telling you 5.7 times 9.8 is 55.1 to one decimal point. So that should be okay. One decimal place, that should be fine. So maybe I could share this. You can manipulate that to work for division or others. Could you combine all the codes and use it as one? Yes, you can do all those things in one program if you want. It's possible. You can do that. For example, we could just put the variables up there, this one and this one and this one, and then you can do all the calculations below. Okay. For example, so with those variables declared there, now you can declare the variables for the answers. You can now say, let's do integers. It's easier to work with integers. So I say int sum, difference, product, quotient, remainder. I think we work with those four. So this one will hold the sum, this one will hold the difference, the product, the quotient, and the remainder. All right. So then what I will do is I'll simply say arithmetic tests like that. So enter two numbers. You enter the two numbers, and they're going to be digits or integers, num1, num2. With those done, now the next thing you have to do here is simply to, so up to that point, you understand the code because we are asking the user to enter value. The user enters num1, num2. Now I want to do all of those calculations below. So the first one will be sum equal to num1 plus num2. Okay. I can display the results here. So I come and say printf. I can say the first number, %d, plus the second number, %d, would be equal to the last number, %d. The values are num1, num2, and the sum. If you remember, we have that done. So let's first run and be sure it's working. So 4 and 5 says 9, correct? Now let us repeat this code, but now for others. So now this one is going to be for the difference. So I'll now say difference equal num1 minus num2. And this will be difference. Okay. Then I'll repeat for multiplication or for product. Product will be num1 times num2. So this one will be the product. I'll repeat. This one will be for the quotient. Will be num1 divided by num2. And this will be the quotient. Now we have the complete program here. Then this one will be for the remainder. Remainder equal to num1 percentage num2. So here this will be remainder. Remainder there. This one will be, just call it remainder. Okay. Yes. And I think those are the ones we have. We have up to remainder. Something like that. So let us see how this program runs. Or if it has errors, we need to remove. I'm going to enter the numbers, like the number will be, the first one is 10, the next number will be 3, 10 and 3. So the program is saying 10 plus 10 is, so that we need to have breaks. When the program ends, we need to have breaks so that new line breaks. After you display that, do a blank line. After you display that, you do a blank line. After you do that, display a blank line. That's what I'm formatting now. After you do that, do a new line. At least that there are spaces in between. 7 and 3. Saying 7 and 7 is 10. Why is it saying 7, 7? I think there's something wrong. Num1, num2. In this one, in some.
Check the printf. It's num1 num1. Somewhere around line.
I changed the code there. All right. I changed the code. Num1 and num1 plus num2. That's correct. Num1 minus this one.
Line 11.
Line 11.
Yeah, check at line 11. The printf.
It's both num1. Yes, you're right. I'd updated that wrongly. So num1 and num2. So let's run this. So 7 and 3. So 7 plus 3 is 10. 7 plus 7 is 4. So we have used a wrong symbol again.
There's num1, then num1 also. Line 13 and line.
The challenge of copying and pasting without editing everything.
Okay,
let's follow that. Let's follow that from the sum. After we get the inputs here, num1, num2. The sum is num1 plus num2, and we are displaying the result. So 1, 2. The sum will go here. Num1, num2 sum. Then the difference is num1 minus num2. And we are displaying those two here, num1, num2 here. And also when we come down here, num1, num2. And we go here, num1, num2. And I think num1, num2, that should be able to sort the mess. So we have our number 7 and 3. So 7 plus 3 is 10, 7. So the symbols now are the ones we need to update for the various cases. The initial one was sum here. So we were doing sum. The next one was difference, minus. The next one was product, so multiplication. The other one was division, so we do that. The last one was remainder. I think it has the name remainder, which is okay. Run. 7 and 3. Num1 is 7, num2 is 3. So when we enter here, so 7 plus 3 is 10, correct? 7 minus 3 is 4, correct? 7 times 3 is 21, correct? 7 divided by 3 is 2. Remember, we are dealing with integers, so it can't keep a decimal point yet. 7 and 3, that means you are extracting the remainder. That's correct, because 7 divided by 3, the remainder is 1. So I think we have put all the arithmetic operations in one program. So I'll just share this file with you. Go and test it out on your own and learn from it as well. The code may not be complete. It's ending up to somewhere here. So let me see why it's ending. Up to where we have the product, quotient and the print below it. Quotient and the print below it. Where is that? Quotient and the print below. So we need to add these small lines for the code to be complete. So I believe you should be able to use that code anyway. So any questions so far based on this? I think this demonstrates how we use this arithmetic operations or operators.
Yes, I have a question.
Yes, ask.
Can you repeat for the one that has sum only, like the first one that we did? Because I'm doing mine and I'm getting error.
What error are you getting? Okay, let me do this. Let me delete the rest except sum, right? Let me get only for sum, then I remove the rest. So up to where we are printing the sum, from there I'm deleting the rest of the code. Up to that point. If I have a number like 87, and I'm adding 54, it says 141. Is that correct? So ask your question from there then. So that's a basic program for adding two numbers. You ask the question, so let me see whether that answers your question. We have 7 minutes left or less. You better be quick.
When I was running it, it wasn't giving me the results of the two numbers.
Okay, is it possible you can paste your code in the chat window so that we can debug that program for you? You can paste your code in the chat section where I've been pasting my code. If you do that, I'll copy it and put it here, then we can together look at it and see whether there's a bug somewhere or you have a different issue on your end.
I am using another device, so I cannot find it.
All right, then just understand the one we are having here. You can take a screenshot. This is working fine, and you don't have to worry so much. Maybe I can shrink the window so that all the code is available. You can take a screenshot. The code is here. You can take a screenshot if you have to, but I've already shared the codes for all of this. So in today's session, we have looked at how to use printf for output, scanf for input, how to do addition, subtraction, multiplication, division, and remainder. The last bit is I want to show you how to use an inbuilt function, another function other than the main. I want to show you how to raise the number to a power, just that, and we end our class, okay? We know that raising a number to a power, if the power is 2, then it's like multiplying the number 2 times. The number by itself, that is. But of course, we may not always know whether we are raising it to power 2 or power 3. So we need a function. We need a function that knows how to raise a base to the power of whatever you call it, an exponent in that case. So we need a file. We are going to include another file for mathematics. So we include the math.h file. This math.h file, this header file, has most of the functions that are supported in basic mathematics. Things like squaring a number, square rooting a value, things like that. You'll be able to find them, including power. Exponentiation, you'll find that there. So in this basic program, which will be our last one in this class, we will have a user enter a number, and the program will be able to calculate, we raise that power, the number to a certain power. So let's see that. So we will need a value. So we will need a number, we can call it the base, and the other one we'll call it the power. Okay? We have a number, the base, and the other one is a power. All of them are integers. Okay? So we are going to ask a user to enter both numbers. So printf, enter the base and power. Okay? Enter the base and the power. The user will type those numbers. Okay? All of them will be considered integers. So we know they're integers. So for now, let's work with integers. Then we ask a user to type. After the user types, we store them. So we have a scanf to collect the inputs from the keyboard. So we'll format the first number as a digit, the second number as a digit or an integer as well. the numbers themselves will be and, base, and power. So we are able to store the numbers entered at the keyboard in base variable and power variable. Now we are going to use a function in math library so that we can be able to store the result. So we also need to store the result. We also need a variable to store the result. So result, there's a variable called result. So I'll say now, result will be equal to, we will be using a function called power, POW. This POW function is found in the math.h library. So it takes two arguments. The first one is the base, the second one is the power. Now I want you to remember, we have two variables. One is the base, the other one is the power. The base could be 2, the power could be 3. Just 2 raised to power 3. That's the meaning. Okay? So if the user enters 2 for base and the 3 for power, then it will calculate it that way. Okay? So then we need to display the results. You could say percentage D exponents this equals this one. And what are those three? The first one is base, the second one is power, the third one is results. Okay. Let's see how that one gives where we get to that. If I try basic numbers like 2 raised to power 2, 2 exponent 2 is 4. Let's run it again. 3 power 3, 27. Let's run it again. 5 power 2 is 25. Let's pick a bigger number. 7 power 5 is 16,805. So that's how you can do raising a number to a power. Let me share the code. Go test it on your own. The remainder operation symbol is the percentage mark. The remainder operation symbol is the percentage mark, percentage sign. So I've shared the code. You can see it's running. You can give it whatever you want. You give it 10 raised to power 2. If you do that, it will give you 100. I would like us to end our class because we have other things to do. We have other classes to attend to. Any questions you have, you can ask me in our next class. Otherwise, thank you and bye for now.